We have the clear understanding of continuous time unit impulse signal, and now in this lecture we will have some discussion on discrete time unit impulse signal. The discrete time unit impulse signal is also known as unit impulse sequence, and it is represented by delta n, and delta n, which is the unit impulse sequence, is equal to 1 when n is equal to 0, and it is equal to 0 for all the other values of n. This means when n is not equal to 0. And when you plot this definition, you will have the sequence like this. You can see that delta n is equal to 1 when n is equal to 0, and delta n is equal to 0 for all the other values of n. Now let's move on to the properties of delta n, and according to the first property, delta n is an even signal. We know if there is a discrete time signal xn, and if we perform the time reversal operation and have signal x minus n, and if signal x minus n is equal to the initial signal xn, then we say signal xn is an even signal. Therefore, if delta n is an even signal, this means delta n must be equal to delta minus n. This means if we perform the time reversal of delta n, we should have the same signal. And in case of time reversal, we simply flip the signal waveform about the y-axis. So if you look at this plot and try to flip the signal waveform about the y-axis, you will find you have the same signal waveform. Therefore, delta n is equal to delta minus n, and we can say that delta n is an even signal. This is all for property number 1. Now we will move on to property number 2, and according to the property number 2, delta n is an energy signal. Now this is one important property. We have calculated the energy of delta n, and we found the energy of delta n is finite. This means the energy of delta n is less than infinity but greater than 0, and therefore delta n is an energy signal. But if you go back to the continuous time signals lectures, you will find delta t, which is continuous time unit impulse signal, is neither energy nor power signal. So delta n is an energy signal, but delta t is neither energy nor power signal. So this is one important property, remember it. Now we will move on to the third property, and according to this property, delta kn is equal to delta n. This means there is no effect of time scaling. Kn means we are performing the time scaling operation and we are getting the same signal. Therefore, there is no effect of time scaling, and we have already solved many examples on time scaling, and if you look at this plot, you will find delta n is only non-zero and equal to 1 when n is equal to 0, and for all the other values of n, delta n is equal to 0. Therefore, when you perform the time scaling, let's say time expansion, this value will remain as it is and all the other values will change, but again all of them are 0, therefore there will be no effect on the overall signal. Similarly, when you perform the time compression, there will be no effect on the overall signal. If your concepts regarding the time scaling of discrete time signals is clear, then this point is very easy to understand. Let's move on to the fourth property, and the fourth property is one important property. We have already used this property in case of continuous time signals. I will quickly write down the property. When we have continuous time signals, let's say xt is one continuous time signal, and then it is multiplied by delta t minus t1, then it is equal to x in place of t we will write t1. So we have xt1 and then this part will remain as it is. Similarly, when we have xn as the discrete time signal multiplied to delta n minus n1, in place of n we will put n1, and hence we have xn1 multiplied to delta n minus n1. This is one important property used a lot. Let's move on to the fifth property. In this property, xn is convoluted with delta n minus n1, and when this happens, n is replaced by n minus n1, and finally we have xn minus n1. Let's move on to the sixth property. In order to understand the sixth property, we will quickly revise the corresponding property when we have the continuous time unit impulse signal. Whenever we have integration, the unit impulse signal delta tau d tau, when integrated from minus infinity to t, the result of integration is equal to unit step signal ut. Now we know in place of integration we have to write the summation. So here we have the summation and we are replacing the independent variable t by a dummy variable tau. Similarly, here we have replaced the independent variable n by the dummy variable k. So we have delta k in place of delta tau, and then we are performing the summation from minus infinity to n, like we are performing the integration from minus infinity to t, and the result of summation is equal to unit step sequence un, like in this case the result of integration is equal to unit step signal ut. So this is all about the sixth property, and now we will move on to the last property, which is the seventh property. According to this property, un minus 1 is equal to delta n. This property is pretty straightforward, but still I will give you the explanation. We are having the unit step sequence un, and we know how its waveform will look. We will have un equal to 1 when n is equal to 0. So we will draw the plot like this. Similarly, un will remain 1 up to n equal to plus infinity. So I will draw the remaining portion roughly. It will look something like this up to n equal to plus infinity, and un is equal to 0 when n is equal to minus 1, and it will remain 0 up to n equal to minus infinity. So this is the plot of un, and to get un minus 1 we need to perform the time shifting, and the time shifting we are having is right shifting, and therefore we will have the waveform which is similar to the waveform of un, but it is shifted towards the right by one integer place. So un minus 1 will be equal to 0 when n is equal to 0, and it will be 1 when n is equal to 1, it will be 1 when n is equal to 2, all the way to n equal to plus infinity, and it will be 0 when n is equal to minus 1, and remain 0 up to n equal to minus infinity. Now subtract the two waveforms and you will find this one, this one, this one, and this one will be cancelled out by all these samples. 0 minus 0 will be 0, but this value here will be there in the output signal, and this is the only non-zero value present in the output signal, and all the other values will be 0, which is equal to delta n. So I hope the seventh property is clear to you, and now I will end this lecture here. See you in the next one.